In this video, we will learn about identification of cations. The identification of cations will be done using two solutions. Number one is NaOH and number two is NH4OH. We know that NaOH is sodium hydroxide and NH4OH is ammonium hydroxide. First, we will prepare a solution of these salts and then we will individually treat them using NaOH and NH4OH solution. The first cation is calcium in +2 oxidation state. Now, when NaOH solution is added in limited amount, we observe a milky white precipitate. This precipitate is due to the formation of insoluble calcium hydroxide, and this insoluble calcium hydroxide still remains insoluble even if we add NaOH in excess. On addition of ammonium hydroxide, we do not observe any PPT. This is because NH4OH is actually a weak base and it does not provide enough hydroxide ions for the formation of calcium hydroxide, and same goes when we add NH4OH solution in excess. Coming to the second cation, that is Cu2 positive, we observe a pale blue precipitate due to the formation of copper hydroxide when we add NaOH in small amount, and even if we add NaOH in excess amount, this pale blue precipitate remains insoluble. On addition of NH4OH, we get pale blue precipitate similar to the case of NaOH, but when NH4OH is added in excess, we observe that this pale blue precipitate becomes soluble and we actually get deep blue or inky blue solution due to the formation of soluble complex which is formed when copper reacts with ammonia. Coming to the third cation, that is Fe2 positive, we observe dirty green precipitate due to the formation of FeOH whole twice when NaOH is added in small amount. Even if we add NaOH in excess amount, we still get this dirty green precipitate and it is still insoluble. On addition of NH4OH, again we get dirty green precipitate and it remains insoluble even if we add NH4OH in excess. Coming to the fourth cation, that is Fe3 positive, we actually observe a reddish brown precipitate in this case because now we get FeOH whole thrice due to the addition of NaOH solution in small amount, and this precipitate will remain insoluble due to the addition of excess of NaOH. On addition of NH4OH solution, again we observe reddish brown precipitate and this remains insoluble even if we add NH4OH in excess. Coming to the second last cation, that is Zn2 positive, we will always observe a gelatinous white precipitate due to the formation of Zn2OH whole twice when we add NaOH in small amount. But this becomes soluble as we increase the solution of NaOH, that is, we add sodium hydroxide in excess. Now this is due to the formation of PPT that is initially formed and then dissolves and gives us a colorless solution when we add NaOH in excess. Coming to the addition of NH4OH solution, we observe gelatinous white precipitate as in the case of NaOH, and on increasing the amount of solution of ammonium hydroxide, again this precipitate becomes soluble because it forms complex with ammonia. The last cation for today is lead, that is Pb2 positive, and we observe chalky white precipitate due to the formation of PbOH whole twice when we add NaOH solution in small amount. And when we increase the amount of solution of NaOH, this becomes soluble and we get a colorless solution. Coming to the addition of NH4OH, we again observe chalky white precipitate and it becomes insoluble even if we add excess of NH4OH. I hope this topic is clear to you. Thank you.